That's perfect. Thank you. Please proceed. Thank you.
Okay, so here to talk about dragons. I want to start with just a quick status, just to remind people that we're currently in a hybrid mode. We have dragons publicly released for all imaging data, all the facility instruments that we currently have. And if you have spectroscopy data, for the time being, you still have to use the Gemini IRAF package. But that is going to change. And currently, we are working on GMOS long slit support. It's split in two big projects. First, the quick look version, and then the science quality version. The quick look version, it's fully implemented and testing is underway. I was doing that this week, the last 2 weeks, and this week between the sessions. So it is proceeding well. And as I said, this is what's coming up. It's going to be released in the next couple months, I would say. It says December to February. I certainly hope I can at least release dragons sooner than that. It's for quick looks. That means it's not science quality. We haven't vetted the science quality yet. That's actually coming up as part of another project. But what this new dragons will offer, well, the quick look, but it fits in an observatory project to do time domain astronomy. So internally, at least, it will come with two new tools. One to automatically create some calibrations, process calibration that we can use to reduce at night imaging data and also GMOS long slit spectroscopy data. At first, this is really just for target of opportunity data. I'm not saying that we won't expand it in the future, but initially, as we get our feet wet in that domain, we're going to concentrate on the TOOs. And this tool called FIRE, the Fast Initial Reduction Engine, will be run at night. So when a TO comes in, the data is observed, it will trigger FIRE. FIRE will, as soon as the sequence is done, it will start reducing, and within minutes, it will upload the extracted spectra to, for example, to the archive for the TOPI to go and retrieve. Again, this is not science quality, but in the context of TO, where as you take the data, you want to know, well, is this really a cool target that I really want more data on? Do I have enough data on this one? Is it really the redshift 1 million that I'm expecting, or is it just a redshift 0.3 that I don't care about? So this is the aim of this reduction, this quick look reduction, to try to guide the TO decisions. So this is coming up real soon. Also, what we're working on, and I estimate it's about 90% of the code is implemented, so it's very, very far along. It's the science quality. So obviously it builds on all the quick look tools that we have, but it has additional correction, like we're going to do the cosmic ray rejection, the slit function correction, and also one big item for the science quality version of the GMOS long slit support is the interactive tools. And I have screenshots at the end of the presentation of the tools that we've created. So currently we have 6 for one for flat normalization, the sky subtraction, wavelength calibration, extraction, and of aperture and the trace, then the sensitivity function. Note that all this actually runs non-interactively, but for science quality, often you really need, depending on your program, the condition of the sky, sometimes you really need to go and tweak to really optimize your reduction. So that's why the interactive tools are part of the science quality package of this support. And you were very close to actually start the science verification, and it will take some time. Personally, my worst case scenario is we release something, you publish a great paper, and then you have to retract it because we screw up. So I really want to make sure that once we release, we would ourselves use it for our own science. So currently the schedule is about a year from now that it would be publicly available. Next in line is going to be the near-infrared long slit. So you see the progression. We're really building the support on top of the previous tools. And in the case of the near-infrared long slit, well, a lot of the GMOS long slit code will be reusable. So unlike the Gemini IRAF, where there's a lot of code duplication, with Dragons, we really try to build on top of what we already have. So it means a bit of an investment at the beginning to write the tools that can be reused. But as we build this foundation, all the new development will come faster. So on top, for the near-infrared, the two big items that we expect will be the sky subtraction, because it's done differently in the near-infrared compared to the optical, and of course the telluric correction. We hope to be able to launch this in early next year, January. We just need, for the people who currently are working on the GMOS long slit for science quality, to finish the work they have to do there in order to move to the next project, which is the near-infrared long slit. So yeah, it's gonna come for about a year after the GMOS long slit with the science. And here I see for the near-infrared, it's science quality. It will also come with a quick look version. And really looking far ahead, our optimal goal is to actually remove our dependency on IRAF. Because as I have another slide about compatibility with various operating systems, we really need to remove this dependency. So when it comes to supporting the other instruments that we have, the near-infrared IFU will be next. It's an image slicer. So that will cover NIFs, GNIRS, and part of the motivation to bring this one up is the GearMOS project, which is also an image slicer. So if we can have some of the core generic tools in time for when GearMOS start their data reduction software, then it will be a very nice synergy between what we need to do and what they have to do. Following that is going to be the MOS for F2 GMOS, and the GMOS IFU will probably be the last mode that we will address. As mentioned before, the GHOST pipeline is already written for Dragons. Scorpio, we're working closely. It's going to be written from that for Dragons. Some code is already in place. So this is progressing well. And I do mention the visitor instruments. We have some visitor instruments who want to start using Dragons. I've started working with the MaroonX people. There's some discussion regarding Halopeke and Zorro. So basically, Dragon's infrastructure is quite flexible to a variety of instruments. Regarding the operating system, just a note to remind people what our current status is. When it comes to Dragons, Linux, we're not aware of any issues. Mac Intel, the Intel chip, we're not aware of any issues. The Mac M1, we haven't really formally tested it. Part of the issue here is we need all the dependencies that we're using must also work on M1. And until recently, I think there was some issues there. I saw a post about 2 weeks ago that somebody successfully installing a bunch of astronomy software on the Mac M1. So I'll have to have a look at that, and we need to test it. When it comes to Gemini IRAF, then it becomes a bit more complicated. Fortunately, Linux, still no issues. Mac Intel, if you run a somewhat ancient OS, so 10.13 and before, it will run natively. But starting with 10.14 and up to now, you must use a virtual machine that James Turner put together. So if you go to our website, it's going to lead you to a page that tells you how to download it, how to set it up. So you really need to use that VM. And it's because Mac removed their 32-bit libraries. For the Mac M1, it is a mess. So we've done some work trying to get the VM to work, but it is very, very messy. So stay tuned. We cannot make any promises whether we will succeed or not, but there's some fairly complicated issues here. And just honestly, I say come to my Dragons workshop tomorrow, and you'll have a little demo of how it runs. But if you're brand new to Dragons, just to give you an idea what the typical workflow is you download your data from the archive, you create your list, and we have tools to really speed things up. If you've reduced data with the Gemini IRAF, you might have used gem list, and you have to know which image number to put into, and then it will create a list for you. Well, none of that with Dragons. We make sure that it's a lot easier. Then you configure a calibration database that will allow automatic association of the process calibration, and then you just go. And what I have on the right is an example of the actual commands that you would have to put in to go from raw data, including calibration, all the way to science. That's all you would really have to type. And we also have an API if you want to code all this. And here's an example just to show you. I said that the code was basically all done, all implemented. So that's a GMOS long sit quick look, run completely hands off. Start with your raw data, and that's the 2D stack. It will stack in spatial and wavelength, size subtraction and extract. If you have more than one source, it will detect the sources and extract them all. And just for the details, standard bias correction, flat correction, QE, mosaic, distortion correction. The wavelength calibration is automatic, and it's very robust. Sky subtraction, the registration, as I said, spatial and in wavelength, the stacking, automatic extraction, spectrophotometry calibration is also automatic. And all this is done with, in this case, just 2 resampling, one for the mosaic and one at the very end when you align things in stack. And this is what our new interactive tools will look like. So you see it's a much more modern look. It's web-based. For those who are technically interested, we're using bokeh. So underneath is JavaScript with what we code in Python. That's how they look. And with that, just self-promotion. Come if you want to know more about how to use Dragons. I'm not going to show how to reduce data, because we have so many instruments, it cannot really be done, but how to customize Dragons. It's a pipeline, it can be run automated, but we are scientists too. We like to tweak and optimize our reductions. So I'll show you a few tricks on how to customize your reduction. And that's what I have. I'm ready to take questions now.
That's great. Thank you, Kathleen. Great to see all the progress. Let's see, I do see we do have a couple of questions in Whova. The first one is, how is Dragons related to packages in the AstroPi ecosystem? Is there a possibility of using Dragons for non-Gemini instruments?
So we use AstroPi heavily. Dragons is a collection of various packages. One is AstroData, which is completely generic. It's not Gemini related. To make it work with Gemini, you have to add another package that provides the layer, basically the translation between, oh, here's Gemini data, here Astro data, how you recognize Gemini data. So in that sense, yes, it is possible to plug in non-Gemini instruments. And in fact, we've done that for SOAR, for example. I can't remember the name of the instruments, but we did play with that. The integration for other instruments at this point, it might be a tiny bit clunky because we're really pushing on supporting our instruments. But intrinsically, the hooks are in there to be used for other instruments. But it does require the person to actually write the layer that will make the system recognize as this or that instrument.
Thanks. The next question what magnitude will the quick look spectral reduction work well to? In other words, will it work well for fainter targets where you would generally need to tweak the reduction?
Well, that's somewhat part of our science verification that we're about to start, trying to answer questions like this, try to figure out what the limits are. From my current testing, I've seen it work on fairly faint stuff. You look and say, yeah, I think there's a line there, and it will find it. So how automatic it will be, that's to come. That's part of the work that is ahead of us in the next year, trying to figure out what the limits are.
Great, thank you. And then, let's see, everything flipped around on me. There we go. One more question here. What are the chief differences between the quick look and science quality versions of Dragons for long slit data reduction?
From the top of my head, there's the cosmic ray rejection. And frankly, if you're using the Yamamatsu and you have a fairly long exposure, it shows. It's a big difference. So we really want, for the science quality, we really need the cosmic ray detection. And then the slit function, this is something that we've always sort of wanted in Gemini IRAF and was never implemented. It was implemented, but never released, so we never managed to finish this one. So that would be nice. We've had report people say, oh yes, we'd really like to have that. So that's another improvement. And from my point of view, it's the interactive tools that really do make a big difference. I found, well, in Gemini IRAF, I always tell people, always run GS wavelength interactively because it fails in half the time. Well, at least in Dragons, wavelength calibration, you'll probably never have to run it interactively. It is very, very solid. One thing that I found I like to do interactively is fitting the sensitivity function, my spectrophotometric star, because it works just as well as with IRAF, but with the interactive tool, you can really tweak it and get something much, much bigger, a bit better. So that's one that I found some really good values in doing it interactively. So yeah, I think that's mostly that. And fundamentally, we will spend months checking the science quality of the output. And I think that's what gets the stamp science quality from our point of view.
That's great, thank you. I see we're at the end of time now. We're going to take a 10-minute break now before we come back with a sequence of 3 talks about future adaptive optics systems. I do see there was at least one more question on the Dragon session in the Q&A, so please go ahead and continue having discussion in that Q&A area following this session. Thank you, everyone, and we'll see you back in 10 minutes after a short break. Thank you.